In this video we're going to have a look at the 2003 an old technical drawing paper question, and in that question we're going to look at the skew lines element. So if you're trying to practice skew lines or master it, great place to look is in the old papers. So anything pre-2009, before the DCG course came in, there was on the first question on the paper there was usually 5 or 6 points given, and it was an intersecting planes question, and then the final part D of the question would have been 2 skew lines. So that's where I pulled this from, 2003 higher level. I changed up the letters, so I just have A, B, C and D. I'm not quite sure, it might have been the line AD and CE or something possibly. So look, I've just changed up the letters. So our 2 lines we're dealing with is the line AB and the line CD, and then we're going to later find the shortest perpendicular distance between those 2 skew lines. Let's start off by getting familiar with our coordinates. So we have our in, up and out, and some people call it in, up, down, but it's in along from the left hand side of your page, in along the XY line, up into the elevation, and out from the vertical plane into plan. So I'm going to start off by coming down about 110 mil from the top of the page. I'm really not certain what direction this drawing is going to take. I'm going to keep it up. I'm hoping that it's going down my page for this. Once I have my XY line drawn, depending on how familiar and comfortable you are with this, mark only 1 point at a time or mark them all. I'm going to mark all my ins, my 100, 110, 175 and 210. I'm going to mark them all. So 100, 110, 175 and 210. Now, as I said, if you're comfortable doing it this way, great. If not, one at a time. From the 100, it's up 35. Up 35 there to point A, and it's an out 70. Out from the vertical plane, as some people call it, down from the XY line, but it's really you're going out from the vertical plane there in plan. What's next is 110 is up 55. I'll actually drop this line in as well. After 110 we are up 55, and that is point D, and we are out 25 from the vertical. So out 25, and that is point D. The 175, that's D done, that's A done. The 175 is up 20, out 90. When you get very familiar with these, you know that it's up 20 and out 90, so it lines up with 90 and mark it on the 0 there, so that's my out 90, and the 90 plus 20 is 110. So if you get very familiar you can start doing that, but probably not advisable for a while anyway. And finally the 210 is up 95. I'll just go from the 100 there, 195. What point is that? That's point B, and it's out 55. And I said that's point B. So there we go, there's our 2 lines, A to B. There. And I'm going to just drop that line in green. A to B in green in the elevation, and A to B in green in the plan. And then we have C to D here in the elevation in blue, and similarly in plan C to D here in blue. So that's my skew lines set up using my coordinates. Just going to heavy in the XY line there over that section. Now I need to, if you're not sure how to deal with skew lines, you need to go back to my introductory video on skew lines. But in that I really take my time and go through the whole setup of this plane. But very briefly, we need to create a plane that contains one line, is parallel to the second line, and has a horizontal edge. Now when you're working through these questions, it can sometimes be difficult to know like what you've got 4 options here straight away. If I contain the blue line and go parallel to the green, that's one way. I can contain the blue line and go parallel to the green down this way. I can contain the green line and go parallel to the blue down here. It's going to get very, very big. I can contain the green and go parallel to the blue up here. Again, it's very big. Really, it's really up to yourself. You know, there's an unlimited number of ways we could do this. And there's no guarantee, like any one of the methods will work, but there's no guarantee it might fit on the page, or it might just end up being a bit awkward. What I'm going to do, I think I'm going to contain the smaller line here and go parallel to the line AB from D down onto a horizontal edge. I think that should work fine. So I'm going to try it. I'm going to try going parallel to AB here in the elevation from point D, and also giving a horizontal edge. I'm not yet going to make that code plane heavy. I just want to see, does it fit there in the plan. That gets me over to here to point 1. And so I just like to make sure that it fits in plan before I commit to it and heavy it all in. I want point 1 done in plan, and I need to follow my rule. So parallel to the green line AB from point D, so parallel to AB, so line up with AB and take it from D. Just check that once more, from point D. So that's looking pretty good there. That gets me point 1, and the horizontal edge along the bottom of it becomes a true length right there. So that's true length TL. Now that looks quite good there to me. That gives me my viewing direction. So for the next view, I'm going to be viewing in this direction right here, down through that true length line, which will give me an edge view of the plane. So that actually looks very good to me. I'm going to now, even though I certainly don't need to do this, I'm going to just heavy in that plane. I'm heavying it in because I'm teaching using this video. I'm not just solving the question and trying to get my marks. You don't need to heavy in the plane, and you certainly don't need to do what I'm doing next for an exam situation. And I'm going adding some colour here, because I think that instead of it just being a collection of lines, we want to think of this as a plane that is relation to both lines. So bit of colour. And there we are. Now, as I said, in an exam you might not be getting the colouring pencils out and doing all that, but certainly for a study sheet you would. So there, parallel, parallel, and we have a horizontal edge along here, which is a true length down below, and down here in plan as well. If I just put maybe 3 dashes through and 3 dashes through to signify that they are parallel. Also, I've created a plane that contains one line, is parallel to the second line, and has a horizontal edge, and I brought that down to the plane. I'm going to just extend on my X and Y a little bit more. The next job I'm going to do is project my auxiliary view looking along in the direction 1C, which is the true length line. So let's go for that. I'm just going to use the sliding set squares altogether for this. I'll take the angle. I'm not going to go right out along. I want to get a decent projection on this, so I'll take the angle of the true length line, and I'll project parallel to that from all of my points. Point D, and finally point B, right there. I'll bring it back down, and I'll set up my X1, Y1 line. Now, I really don't know what this is going to end up looking like. I'm going to go out a bit further here with my X1, Y1 line. I know that B is going to be the furthest away. I'm going to go out a good bit there with my X1, Y1. That could have been a good move, or it might not have been. We'll see. I'm going to extend my projections a little bit further now. And now I take the compass I need the distances out in this elevation, and they're going to be the same as the heights in this elevation. So the closest one to me is C. C and 1 falling at the same point as first of all. A is next. D is next, and if you want to label as you go along, you're welcome to. I'm going to go and just drop in all of my points to start. Finally, we have B. What we have here, so we have A and B, and in blue we have C and D. Just to safeguard myself and ensure that I've done this accurately, I will line up with A and B, but I won't draw it. So I'm taking the angle of A and B, and I'm checking, because that projection should give me a view showing the two lines as parallel. And it has. C and D are good, A and B are good. So I'm very happy now that they've lined up perfectly. I use my sliding set squares to just ensure that they're lining up before I commit and start drawing one line and realizing it's off and maybe having to go back and make some changes. Now, what are we looking at next? What we're looking at next is the shortest perpendicular distance, so we're going to view perpendicular to the lines. If it says shortest perpendicular distance or just shortest distance, we look perpendicular to the lines. So let's go and do that. I'll take the angle the lines are set. I'll use my adjuster this time. And I'm very far down on my drawing board here, so it's just to take real care that this is set accurately. And I'll lock it in. So I'm happy there. I'm going to project off at 90 degrees to those lines. So I get C. I'm going to actually, I might just shorten up this XY here a little bit in the original so they're not overlapping. C. I get point A, D, and B. I'll extend on through C just a little bit further, and I'll drop in my x2 by 2. Now, final step before we get our correct answer and bring it back through the views. If I want the distances out to this view, I'm going to skip one view here and work back. Now, I'm not going to be setting my compass that big, so instead I'm going to just bring in a reference. I'll take the angle of my x and y one, and I'm going to reduce everything. So I might reduce it right back there to point B, and just put that in there with a colour and just call that REF. It's a reference or a reference line. What does that do? It means that I am subtracting probably about 70 or 80 mil from all these. So instead of setting my compass huge here, I'm just subtracting all my bit of space. So instead of putting my compass on the X and Y one, I'm back here to put my compass on the orange line. B is at a 0 measurement, so it's on the orange line, which means B is on the X and Y one. C is the next back from the orange line. C, and always follow through your views so that you're on the correct line. A is the next up. Follow through your views to A, and finally point D is the last one up. D. So I get D here being the furthest away, projected to the furthest away position at D. I get A being the next one in, projected to A. And the B is the closest, and then C is next, projected to C. So if I draw my two skew lines as they appear to cross in this view, so in the last view I had them appearing parallel because I got an edge view of the plane that relates to both, and this time I have them appearing to cross. And where they appear to cross gives me point view of shortest distance. Or a point view of the shortest distance line. If it's a point view, I'm going to bring it back through my views now. So there it is. Take it from there and check my adjustable. Make sure that hasn't changed angle when we dropped it or anything, and bring it back through the views, and there we have it. There's the shortest distance between the two lines. If it's the shortest, if it's a point view on one, if it's the point view up here, it has to be a true length, TL of shortest distance. What else does that mean? Well, that also means that if I extended it down onto my X and Y one, that's a true inclination that makes it to the horizontal plane. But we weren't asked that in this question, so we won't focus too much on that. The shortest distance line goes from point 1 to point 2. Let's bring it back to the plan. I'll set up my angle, my original projection angle right here with my sliding set squares. Point 2 is on the green line. Point 1 is on the blue line. So there's the line, joining 1 to 2. There it is in plan. In the elevation, point 1 on the blue line, point 2 on the green line. And we are very nearly there now. Point 1 to point 2 in the elevation. There's the shortest distance. Now, the very last little thing to note here is this. That's the question finished and answered, okay? The projections of the shortest perpendicular distance. It goes perpendicular to both lines. What we do need to know is this as well, though. If, let's just say for argument's sake, we didn't have quite enough space and that was the edge of our page and the full plane here would not fit on. What I want to show you is this. And the question is finished. This is just a side note. I can contain the blue line up to that point right there. Okay, I'm going to call that point M. I can contain the blue line up to point M. I can go parallel to the green line and I can go horizontal. Okay, and that's me gone horizontal until I hit point N. That portion of the plane that only goes down to here will solve the question exactly as the full plane will solve the question. So if you happen to be dealing with a really awkward question, or maybe you have positioned your views way too close to the side of the page, or whatever the case may be, this is handy to know that I have right now applied the plane correctly. I do contain the blue line, but just a portion of it. I do have a parallel edge to the green line and I have a horizontal line. What does that look like down in plan? Well, point N is there, parallel to the green again. That will give me point N. But the big thing you cannot forget then is that N horizontally does not bring you down there to C, of course. It brings you N to M. So N to M here would be direction of your plane that we would view. So that grey plane I have shown in elevation, if I just even use the pencil quickly to just add a bit of shading to this, hopefully you'll understand it then, that this grey plane here will do the very same job as that much larger orange plane. But sometimes understanding that you can cut the plane down and not quite go the full size can solve the odd question and can get us out of a tricky one. The big thing to know here is that each plane does the same job. So if we don't have enough space, let's just say we were limited in our space for whatever reason. If we don't have enough space, you can do what I just did there. You can go down a portion of the blue line and then go across, and then you're parallel to find your point. It doesn't have to be the full blue line, for example. The reason that works just fine is this. The true length line that we had on the original that gave us our viewing direction to find both lines parallel, well, that angle is the exact same as the N and M angle. They're both parallel. It's just this, it's the exact same plane, but increased up to full size or reduced down to smaller size. But the viewing direction will be the exact same for both. So both planes, the smaller grey and the larger orange, both planes will result in your lines appearing parallel and will then result in your lines appearing across, giving us the shortest distance. So there we go, that's just a little extra explanation in there and a little extra brainstorming if you happen to encounter a situation where you're maybe tight on space, or just if the question is posed in a way that will require you to use a reduced size plane like this one here. Now that is the end of this question here, so I hope this video has been helpful. If it has, like the video please, and if there's any more you'd like to see, just drop a comment on down below. Thanks very much.